On to number 11. A ball is dropped from the top of a 250-foot cliff. The height of the stone, are we talking about stones or ball? Well, okay, so, all right, so the height of the ball above the ground, t seconds after being dropped, is h equals negative 16t squared plus 256 feet. Find the amount of time it takes for the ball or stone, whatever it is you're dropping, to hit the ground. Okay, so yeah, another word problem. If it helps, draw a picture. So here's the cliff, right? Here's the ground. We know that this is 256 feet above the ground. So take your ball or stone or whatever, drop it, and it's going to fall to the ground. How long does it take to reach the ground? That's the question. Now the ground is a height of 0, right? Because this is a height of 256 feet, right? So we'll just call the ground level 0, 0 feet above the ground. That's the ground, right? So that's the whole idea here. Just take h, negative 16t squared plus 256, that's given, and just set it equal to 0. So to find the time, we just have to solve this equation. Right? And it is a quadratic equation. And my guess is that we're supposed to do this by factoring. So if you do it by factoring, you factor out the negative 16, and you get t squared minus 16. So the negative 16 doesn't matter. You can divide by it. And so now you just have to factor t squared minus 16, which is just t minus 4 times t plus 4. Right? So we get two answers. From t minus 4 equals 0, we get t equals positive 4. And from t plus 4 equals 0, we get t equals negative 4. And these are going to be in seconds, right? So negative 4 seconds was 4 seconds before we dropped the ball. Well, that doesn't make any sense, right? So it's going to be 4 seconds after we drop the ball, right? So here we can ignore the negative answer. So the amount of time it takes is 4 seconds. Right. So it turns out that you could have also done this by the square root method, right? Now, at the time we learned about this problem was way back in chapter 6, I believe. We didn't know about the square root method because that's chapter 11, and we went in order. All right. But so doing this by using the square root method, just subtract the 256 from both sides. And you get negative 16t squared equals negative 256. Divide by negative 16 on both sides, and you get t squared equals 16. So take the square root of both sides. Don't forget the plus or minus. So t is plus or minus the square root of 16, but the square root of 16 is 4. So you can see we get the same two answers as before, right? We get t is equal to positive 4 seconds, and t is equal to negative 4 seconds. Oops. Negative 4 seconds. But we're going to ignore the negative 4 here, right? So if you forgot the plus or minus, as a lot of students tend to do, well, you lucked out in this case because we're only looking for the positive answer. Because time is generally positive, going forward. Negative time you can think of as going backwards. So, in some cases you might want to think of a negative time as just going backwards in time. But yeah, that doesn't make sense for this problem. So yeah, so you would have gotten the right answer, but again, if the problem were just solve the equation and we don't know what t represents, we do want both answers. In this case, if you forget the negative 4 seconds, you would get points off for that. So don't lose points for forgetting the negative answer when you need it. In this case, we didn't need it. So, all right, number 12. Right, so we want to find the domain of the following functions and write the answers using interval notation. Right, so this was in chapter 8. This was 8.1 and 8.2. So, we didn't do chapter 7 yet, so this is a little out of place. yeah, some of these problems are not in the correct order, but don't let that bother you. Generally speaking, the final exam will go in order, but not all of these problems will. Okay, so finding domain, we remember how to do that, right? Given the function f of x, it's capital F here, is equal to 3x minus 4 over 6. So remember, when you're dealing with fractions, you just take the denominator, set it equal to 0, and solve for x. Well, 6 does not equal 0, so this equation has no solution. And if the equation has no solution, what does that mean for the domain? It means there's nothing we have to eliminate from the domain. The domain is everything. It's all real numbers. Positive numbers, negative numbers, fractions, decimals, all real numbers, right? So everything going from negative infinity to positive infinity. So in interval notation, the way we express all real numbers is the following. We use parentheses, negative infinity to positive infinity. And that's the answer for part A. Right. For part B, we have g of x is equal to, let's see, 4x minus 7 divided by 2x minus 3. Okay, so finding the domain is done the same way. We're essentially finding the restricted values, right? Take the denominator, set it equal to 0, and solve for x. So let me add 3 to both sides. We get 2x equals 3. And then divide by 2. We get x equals 3 over 2. Right? This is not the domain, right? This is the restricted value. Right? And they haven't asked for that yet, but if the question is what's the restricted value, the answer would be 3 over 2. But here they're looking for the domain. The domain is everything else. All the other numbers except for 3 over 2. Right? 3 over 2 is 1.5. So all we have to do is just erase that one number and represent all the other numbers. All the numbers less than that number, or all the numbers bigger than 3 over 2, right? So this is x is less than 3 over 2. This is x is greater than 3 over 2. But in interval notation, you're going from negative infinity to 3 over 2. Or we're going from 3 over 2 to positive infinity, and just join them together with a union symbol. Take the union. And that's the answer for part B. Right? For part C, again, we want to find the domain of this function, 3x minus 15 over x squared minus x minus 20. So to find the domain, essentially, first we find the restricted values. We just set it equal to 0. And when we solve this equation, any restricted values that we get, we throw out of the domain. Okay, so how do we solve this equation? Well, it's a quadratic equation, so there's a lot of ways you can solve it. I'm going to do it by factoring. I'm going to do it pretty quickly, right? We're looking for two numbers that multiply to negative 20 and add to negative 1. So negative 5 and positive 4. Okay. Hopefully you worked that out already, right? So x minus 5 equals 0, x plus 4 equals 0, so we get two solutions, 5 and negative 4. Again, that's not the domain. Those are the restricted values. So the domain is all other numbers. So we exclude the negative 4 and the positive 5. So we want everything less than negative 4, everything between negative 4 and 5, and everything bigger than positive 5. So we're going from minus infinity to negative 4, union, everything from, negative 4 to positive 5, and another union from 5 to positive infinity. So that's the interval notation for the domain. Essentially, it's just x that's not equal to negative 4 and 5. And sure, that might be an easier way or quicker way to express the domain, but they're specifically looking for interval notation. You got to get used to that too. All right, so part D is actually very similar. I'm going to skip that one. So part E is one that you probably don't have to worry about, because I don't think we really went into this. So this is sort of a relic of days when we used to cover a little bit more. So just to give you, right, how you find the domain of a square root function, in case it comes up, whatever's under the square root cannot be negative. It has to be greater than or equal to 0. Right? Remember, if it is negative, you get an imaginary number. And we want to avoid imaginary numbers for our functions. We want nice real numbers, right? So all we have to do is solve this inequality. And the way to do that is, well, let's add the, let's subtract the 3 from both sides. I take it most of you would do that, right? Negative 4x is greater than or equal to negative 3. Now we divide by negative 4. And we get x is greater than or equal to positive 3 over 4. Unfortunately, that's the wrong answer, right? So this is why this can be a little bit tricky here. The reason why this is wrong is that because we divided by negative 4, the greater than or equal to symbol has to change to less than or equals, right? You have to switch the direction of the inequality here. So, yep, this is not going to be less than or equals. It's going to, not going to be greater than or equals. It's now going to be less than or equal to 3 over 4. Okay. Oh, and in interval notation, well, here's the number line, right? Here's 3 over 4. Everything less than that is to the left. So we're going from negative infinity to 3 over 4. And here's where we use a bracket because of the equal sign. Right? Everywhere else, right, we did not have an equal sign. When we had less than, strictly less than, we use parentheses. But when you have less than or equals, you use a bracket. So this is the answer for interval notation for 12e. Again, I don't think it's going to come up on a test, but just in case, there it is. And so for 12f, it's very similar. Okay, number 13. So we're still looking for the domain of a function. Oh, actually domain and range. But we're not given the equations of the functions, right? As we were in number 12. We're just given the graphs. And in fact, it's usually easier when you look at the graphs how to find the domain and range, right? Remember, domain is just all the x values, right? So for part A here, right, what are the x values? Well, there's nothing to the left of negative 3, right? So we're starting at negative 3, and we're ending at, it looks like 5, right? So we're just going from negative 3 to positive 5. And we're including the negative 3 and the positive 5, so we'll use brackets. So this is the domain for, part A. What about the range? So if the domain are the x coordinates, the range are the y coordinates. So what are the y coordinates? Well, the smallest one is the lowest point, which is, it looks like negative 2, right? And we're going all the way up. So this is y equals 4. But we go above that, right? We go 5, 6. Looks like it tops out at 7. So all the way from negative 2 to positive 7. So it looks like the range is, again, negative 2 to 7. And that's an interval notation. Right, what about part B? So part B, let's go back to the domain. So the x values range from negative 4. And it looks like we stop at 1 here. So let me write that down. For the domain, we have negative 4 to positive 1. Right? And again, I'm using square brackets because these are not holes here. Right? We include these points. But notice that there's nothing between 1 and 3. all of this is blank here, right? There's nothing here. So we have to skip over that. So let's form the union. So where do we rejoin the function? Starting again here at 3 and going all the way to 8. So from 3 to 8. Okay, so that's the domain. They also ask for the range. So the range, again, are the y coordinates, the y values. And the lowest y value here is -4. And we go all the way up to, well, this is y equals 2 here, but we keep going all the way up until the highest point. The highest point looks like at y equals 6. So for the range, we're just going from -4 to +6. Okay, so that's how to find the domain and range, just looking at a graph. All right. Okay, moving on to number 14. Number 14 is we want to simplify the following rational expressions, aka fractions, right? So whenever you see the word rational expression, we really just mean that it's a fraction, right? And these are clearly fractions. But specifically, rational expression refers to the fact that the numerators and denominators are these polynomials, right? Trinomials, right? Binomials with 2 terms, or even polynomials with 4 terms. Okay. So what do we mean by simplify? So simplify, again, it means a lot of things in math, but particularly to fractions, it's just 2 things. Factor and factor everything, right? Numerator and denominator completely. Right? And then cancel. And what do I mean by cancel? Cancel any common factors from the numerator and denominator. Right? So for example, if I have 7 divided by 7, we know that's just equal to 1, right? So x minus 2 over x minus 2 is also equal to 1. Anything that's the same in the numerator and denominator can be canceled, as long as they're factors, right? So be careful you don't make the following mistake. If I have x divided by x plus 4, right, that's as simple as it gets. You cannot cancel the x's, right? Because the denominator is not factored, right? It's not x times 4, it's x plus 4. Right? So this is already simplified. If I had x over 4 times x, well, that's different, right? You're multiplying, not adding. So you can think of this as 1x over 4x. So in that case, sure, the x's cancel, and you can write this as 1 over 4. Right? But not in the case where you're adding or subtracting. Okay, so with that out of the way, we can start part A here. Part A is we want to simplify 6x minus 18 all over 4x squared minus 12x. Okay, so step 1, factor. So we have to factor the numerator. And I hope that's easy. Just factor out the GCF of 6. So this is 6 times x minus 3. And what about the denominator? The denominator, the GCF here is 4x. So factor out the 4x, and you just get x minus 3. Oh, sorry. That's all we need to do here. I thought it was 2 steps, right? So 4x times x minus 3. Right. So x minus 3 is a factor of the numerator, and it's a factor of the denominator. So I can cancel those, and we're just left with 6 over 4x. But we're still not done, right? Because 6 you can factor as 2 times 3, and 4 you can factor as 2 times 2. Right? Don't forget the x, because it's 4x. So 2 is also a common factor. 2 divided by 2 is 1. So this is really just 3 over 2x. And now there's nothing left to cancel, so that's our answer for part A. Makes sense? Right, let's try B. So 2x cubed minus 16 over 8x squared plus 16x plus 32. So I can tell this is going to be a bit of a challenging one, right? So again, the directions are just to simplify, right? And this is 14b. All right, so again, step one is to factor. So to factor the numerator, we can factor out a 2, so that's the GCF. But notice that x cubed minus 8 is also factorable, and that's going to be your usual a cubed minus b cubed. And I think we did this earlier, in an earlier problem. So it just ended up being x minus 2 times x squared plus 2x plus 4. So that's the numerator. Now we have to factor the denominator. The GCF here is 8, so if we factor out an 8, we're left with x squared plus 2x plus 4. Oh, and that's good news because that's also in the numerator, right? So whether or not we can factor x squared plus 2x plus 4, and I'll tell you right now it's not factorable, it is prime. But in this case it doesn't matter because we just cancel that common factor in the numerator and denominator. And we're left with 2 times x minus 2 divided by 8. However, 8 is 2 times 4. So again, cancel the 2's, and you're left with x minus 2 in the numerator divided by 4 in the denominator, and we're done. Okay? Yeah, don't go any further. You might think, well, wait a minute, isn't 4 2 times 2, and I can cancel the 2's? No, you cannot because you're subtracting, not multiplying. So whether you're adding or subtracting, you cannot cancel the 2's here, right? So this is our answer, and don't try to go any further than that. Part C, well, I was going to skip it, but let's do it quickly. Because this is a pretty typical problem. This is one that we like to put these on tests because they're not difficult if you know what you're doing. If you don't know what you're doing, yeah, it can be pretty tricky. So remember, to simplify this, we need to factor and cancel. So how do we factor the trinomial in the numerator? Well, the GCF is 1, so we look for two numbers whose product is -4 and whose sum is +3. And you don't have to look very far for that. It's just going to be +4, -1. So 4 times -1 is -4. 4 minus 1 is 3. In the denominator, what two numbers multiply to 8 and add to 6? So it's not 8 and 1. It's got to be 4 times 2 is 8. And 4 plus 2 is 6, right? So we can see what our common factor is. It's just x plus 4. So we cancel that, and we're left with x minus 1 divided by x plus 2. Right? And don't cancel the x's because they're not factors. So, yep, if you write an answer of -1/2, it's wrong. So don't do that. Your final answer should be x minus 1 over x plus 2. Right? Again, you can cancel factors like x plus 4, right, because you're multiplying here. Right? But you cannot cancel terms. You cannot cancel things you're adding or subtracting. All right, I'm going to do D because it's probably one of the more difficult ones. You get 2xy plus 2x minus 3y minus 3 all over 2xy plus 4x minus 3y minus 6. Right. Looks tricky, but again, it's just a matter of how good you are at factoring. Right? And we just did a whole bunch of factoring problems not that long ago, so hopefully it's not too bad. Yeah, again, just be careful you don't get sloppy here, right? You cannot cancel the 2xy's because they're not factors, they're terms, right? See, you're adding, not multiplying, right? If you had parentheses around everything here, now you're multiplying, and now you would be able to cancel. But that's not the problem. There's no parentheses. You can't just put them there, right? So yeah, what you're going to have to do is factor the numerator. And because the GCF is 1, and that's true for the denominator as well, by the way, we're going to have to factor by grouping. So let's do that down here. Remember how grouping works? Because you have 4 terms, you split it up into 2 and 2. So for the first 2 terms, you can factor out the 2x. So 2x times y plus 1. And then for the last 2 terms, you factor out the negative 3. So it's negative 3 times y plus 1. So you can factor out the y plus 1 and multiply by 2x minus 3. Okay, so that's the numerator, y plus 1 times 2x minus 3. For the denominator, well, again, let's just write it out term by term here, and then split it up. The first 2 terms, you can still factor out a 2x, but now you get y plus 2. And from the last 2 terms, you can factor out a negative 3, and the other factor is y plus 2, right? So you factor out the y plus 2, leaving you with 2x minus 3. So this is y plus 2 times 2x minus 3. Lo and behold, 2x minus 3 is a common factor, so you can cancel, and you're left with y plus 1 over y plus 2. Again, don't cancel the y's. That would be a big mistake, so don't make that mistake, right? All right, so that's simplifying rational expressions. And number 15 is really more of the same. It's just, right, factoring and canceling. And in fact, in part A, there's really nothing to factor except the numbers. I really should skip this one, but all right, let's do it quickly. So 4x cubed over 9y to the 4th times 15x squared y to the 7 over 16x to the 9. Okay, so again, factor and cancel, right? So let's start with 4x cubed. That's just, well, 2 times 2, right? And then x cubed times x squared is really just x to the 5 times y to the 7. Right, what about the denominator? 9 is 3 times 3. 16 is 4 times 4. But be careful, 4 is not a prime number. 4 is 2 times 2. So it's really 2 times 2 times 2 times 2. And then we have, let's see, x to the 9 and y to the 4. So what can we cancel? One of the 2's, 2 of the 2's, and that's it. Right? And then you just subtract the exponents, right? 5 minus 9 is negative 4. And 7 minus 4 is 3. And then in the denominator, we have 3 times 3 times 2 times 2. So that's 9 times 4, which is 36. Remember, no negative exponents, so we should bring that downstairs. We get y to the 3 over, x to the 4 times 36. 36x to the 4. Okay, so yeah, you practically could have done this. This was really a Chapter 5 problem as a review, right? So there's really nothing difficult about this. So let's go on to Part B. So remember, we want to multiply and simplify, right? But it's really just simplify here. We'll multiply later if we have to. So again, factor and cancel. Right. It's just like we did in the previous number 14. Yeah, this is number 15b. Right? Cancel. So factoring the numerator here, well, we can factor out a 5, and that leaves us with x squared minus x minus 6. But it turns out we can factor that as x minus 3 times x plus 2. The denominator, right, this is just a squared minus b squared. So a minus b times a plus b, or x minus 2 times x plus 2. All right, what about the second fraction? So the numerator, you factor out the GCF of 2, and you're left with x minus 6. For the denominator, you factor out the GCF of 8, and you're left with x squared minus 3. Just wondering if I wrote this down correctly. Oh, I forgot an x. Sorry. Hang on here. Yep, there's supposed to be 24x here, right? So, yeah, so the denominator is wrong here. Let's try that again. I just wrote it down wrong, right? So the denominator here is 8x squared minus 24x. So the GCF is not just 8, it's 8 times x. You can factor out the x as well. All right, and that leaves you with x minus 3. So it's not x squared minus 3. Good. Okay, so, yep, so we have 2 times x minus 6 on the top, and we have 8. 8, by the way, is 2 times 2 times 2, and then times x minus 3. So if I'm not mistaken, I think we're factored completely here. So that takes care of the factoring part. Now comes the fun part, canceling. Anything that's the same on the top and bottom can be canceled, right? So x plus 2 divided by x plus 2 is 1. We can cancel those. 2 divided by 2 is 1. We can cancel those. X minus 3 over x minus 3, even though it's way over here, as long as 1 is in the numerator and 1 is in the denominator, yep, they cancel as well. All right, so I think that's it. So what's left over in the numerator is the 5 times x minus 6. And in the denominator, we have 2 times 2, which is 4, times x minus 2. Okay, so I think there's nothing left to cancel. So I think that's the answer for 15B. And you'll notice in the answer key that I also wrote down if x is not equal to negative 2 or 3. And I'm not usually particular about that. Why did I write that down? Because we canceled the factor of x plus 2 and the factor of x minus 3. So they were both in the denominator. These were our restricted values, right? The negative 2 and the 3 were restricted values. So these will only be equal as long as x is not negative 2 or 3. But in the end, I really just want the simplified version here. So, oops, I can't spell simplified. Yeah. Okay. So, yeah, you don't need to put the if x is not equal to negative 2 or 3. I'm not requiring that. On the other hand, you should be aware of it, especially if you're going into college algebra, that these are restricted values. They're not in the domain of the original expression here. And you can say that that positive 2 isn't as well, right? Because that's a restricted value. The point is it's a restricted value of both the original and the simplified version. So, all right, moving on to part C. All right. So again, we want to simplify, or multiply and simplify. But remember, it's really simplify and then multiply. And in this case, simplify, again, just means factor and cancel. So we can't cancel anything yet. Don't even try, right? Don't cancel the x squares. That's going to get you in big trouble because you're just not going to get it right if you do that. So yeah, what do we have to factor? The numerator, the denominator, the second numerator, and the second denominator. So it's essentially 4 factoring problems all in one, right? And so this could take quite a while. And I'm just going to let you do that. It's good practice, right? It's good practice for factoring. Most of these are AC method. So make sure you know the AC method. Okay? So I hope you got it, because I'm just going to write down the answers here. So this is going to be, well, I know the 3's go here. Where's the negative sign go? It's going to be 6 minus 3. So positive here, negative here, right? And then for the denominator, this is going to be 3x times x for 3x squared. Where's the 7 go? I think it goes here. That means the 1 goes here. And so this is going to be a plus 7 and a minus 1. The second numerator should be easy because it's not the AC method. It's just what two numbers multiply to 14 and add to 9. So it's not 1 and 14. It's just 2 and 7. And then for the denominator, we get 2x times x. And 6, it's either going to be 3 and 2 or 6 and 1. So I think it's going to be 3 and 2 this way. So 4 minus 3 is 1, right? So I think that's it. So I know I did that quickly, but I was hoping that you could do all of these on your own. Again, if you're having trouble factoring, go back to, I believe it was number 9. Yep, number 9, we did a whole bunch of factoring problems just like that. So, all right, so that's the factoring part. And again, that's the tedious part. That's the part that takes forever. Now comes the easy part, the canceling. So we're looking for factors that are common to the numerator and denominator. We have 2x plus 3 in the numerator. I'm sorry, 2x minus 3 in the numerator. And we have 2x minus 3 in the denominator. They get canceled. We have an x plus 2 in the numerator and an x plus 2 in the denominator. They get canceled. And we also have an x plus 7 in the numerator and an x plus 7 in the denominator. They get canceled. So the only thing that survives the numerator is the x plus 3. The only thing that survives the denominator is the 3x minus 1. And there's our answer for part C, 15C. Okay, and 15D is very similar, so I'll let you do that. For 15D, you will need, though, the difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So once you know that, I think 15D is really not that difficult. All right, 16. Okay, so for number 16, we're going to divide and simplify. Very similar to multiply and simplify, but with one extra step, as I'm hoping you remember. So for 16a, we have x plus 4 over 2x squared minus 6x divided by x squared plus 2x minus 8 over x to the 4th minus 9x squared. Well, before you do any factoring, any simplifying, I would just keep change flip. So keep the first fraction. You're going to change the divide to multiply, and then you're just going to flip the second fraction. Right? Just flip it over, take the reciprocal. Okay. Right. So that's the first step. Now it's a multiply problem, right? And we've done several of those already. So let's just do another one. So the first numerator is x plus 4. That's prime. There's nothing we can do with that. For the first denominator, the GCF is 2x, so let's factor out the 2x. Okay, so far. For the first numerator here, x to the 4th minus 9x squared, the GCF is x squared, so we can factor out the x squared, so it's x squared times x squared minus 9. However, x squared minus 9 is not prime. We can factor that as the difference of squares, a squared minus b squared. So we get a minus b times a plus b. Or in this case, right, x minus 3 times x plus 3. And the denominator, x squared plus 2x minus 8, that's just a usual trinomial. The two numbers that multiply to negative 8 and add to positive 2 are plus 4 and minus 2. Okay, so I think that's everything. Now that we're factored completely, what can we cancel? X plus 4, right? and x minus 3. And I think that's it. Let's see, what do we have left over in the numerator? We have x squared, so that's x times x plus 3. And in the denominator, we have 2 times x minus 2. So you can see I wrote it this way because we're not done. X is also a common factor, and so that factor of x cancels. So now we're done. This is x times x plus 3 all over 2 times x minus 2. Oops. That's supposed to be an x. Okay, good enough. Right. And then for 16b, right, we're dividing 2x squared minus 8x over 12x to the 4th minus 12x cubed by, right, divided by x squared minus 16 over x squared plus 3x minus 4. All right, well, first, before we do any simplifying, let's just keep change flip, keep the first fraction exactly as it is, for now anyways. Change to multiply, and then flip the second fraction, right? Take the reciprocal. Okay. Right, now we just factor and cancel. So from the first numerator here, we can factor out the 2x, and we're left with, it looks like x minus 4. For the denominator, we can factor out a 12 and an x cubed, and that's just x minus 1. For the second numerator, x squared plus 3x minus 4. Let's see, negative 4 and 1. No, that would be negative 3. Right? So I think we want positive 4 and negative 1. That adds to positive 3, right? And then x squared minus 16, we've done this many times, x minus 4 times x plus 4. Okay. So when you just multiply across. I don't think I emphasized that in the previous problem. If you're wondering, why can I cancel the x plus 4 in the first numerator with the x plus 4 in the second denominator? And the answer is that, right, you can just think of this as one fraction, right? As long as you have one factor in the numerator, one in the denominator, that's all that matters, right? The same goes for the x minus 3. Even though they're in two different fractions, when you multiply, you're just multiplying across. So by extending this little fraction here, the little line, I'm just multiplying across, right? And so if it bothers you, yeah, you can always do that, right? You can multiply, you have x minus 4, x minus 1, x plus 4, all in the numerator. And then in the denominator, we have 12, x cubed, x minus 4, x minus 1, x plus 4, right? You can see why I wrote it in that order, because, everything cancels, right? Not everything, but you can see x minus 4 here cancels with this x minus 4. So that's just writing them on top of each other like that. And the x minus 1 cancels with this x minus 1. Same thing here. And finally, the x plus 4, that was already on top of each other, x plus 4. So everything here that I circled cancels. And so it looks like we're just left with 2x over 12x cubed. But we're still not done, right? There's nothing we can do with the 2 times x, but 12 is 2 times 6, and x cubed is x times x squared. So as it turns out, we can cancel a factor of 2 and a factor of x. After we cancel those, we're left with, well, something over 6x squared. So what's the numerator here? Right? It's not 0. There's always an invisible 1. Right? When you cancel everything, what's left over is not nothing. It's a 1. Right? So this is 1 over 6x squared. Okay. Yeah, so be careful when you cancel everything in the numerator, right? There's always that invisible 1 hanging around, right? This is 1 times 2x, right? Even though we don't usually write the 1. But here we have to, right? Because if you just write blank over 6x, you know, you're missing something. What is the numerator here? And it's just a 1. So please write the 1. All right, number 17. Actually, this is a good place to pause and start a new video. So yep, I want to make these shorter videos. So if you notice, I'm making more parts to the video. Yeah, more parts, but they're shorter. So I hope that helps.